Hello once again. Continuing our series in public health engineering, in this program we will see as how to measure the optimum dose of coagulants. As we know, the raw water contains some suspended impurities. Some of these can be removed by a simple process called plain sedimentation, but the very fine and colloidal impurities cannot be removed by it. These are removed by a process called coagulation. Coagulation is a process in which the finer particles are made to combine together by use of a reagent called coagulant. The finer particles, after combining, make a bigger flock, become heavier and will settle down under gravity. In order to ensure maximum efficiency and economy, it is important to determine the optimum dose of coagulant. Optimum dose is the minimum dose or the strength of coagulant that will result in maximum turbidity removal. This is done by using a jar test apparatus. The apparatus consists of a stirrer having 6 pedals . These pedals can be independently moved up or down and locked in position. An electric motor operates this stirrer. We have speed control to regulate the speed between 0 to 130 rpm, a timer to prefix the time of coagulation. The base of the metal housing is provided with a transparent sheet that can be illuminated by a tube light. At the top we have a counter that measures the number of rotations. This is helpful in measuring the speed. In addition to the apparatus, we require some glasswares. We need 6 glass jars, each of capacity 1 liter. A measuring cylinder of capacity 1 liter, pipette of capacity 10 ml or higher, a raw water sample has been collected. About 20 to 25 liter of the sample is required. First, make the sample homogeneous by stirring. Now measure 1 liter sample. And fill in the beaker. In the same manner, we will fill all the beakers. There are various coagulants that may be used. Alum and ferric chloride are commonly used coagulants. Between them, alum is more frequently employed. We will measure the optimum dose using alum as the coagulant. Now, here we have prepared a alum solution of concentration 1% by dissolving 1 gram of alum in 1 liter of distilled or deionized water. Now, we will add a varying dose in all the beakers. The dose shall be dependent on the turbidity level. In this case, we shall start by adding 5 ml in the first beaker and then giving an increment of 5 ml in each subsequent beaker. So, here we have added 5 ml, in beaker 2 we will add 10 ml, 15 ml, 20 ml, 25 ml and 30 ml of the dose. In order for more precise evaluation, measure color, turbidity, alkalinity and pH value of the raw water. Now, place the beaker on the platform of jar test apparatus. Now, we will lower the pedals and lock them in position. Now, stir the sample for 1 to 2 minutes at a speed of about 100 to 120 rpm. Then reduce the speed to 20 rpm and run it for 20 minutes. After stirring is complete, switch on the light and allow the flocks to settle down for some time. Then observe the extent of turbidity removal in all the beakers. In this case, the maximum turbidity removal with the minimum dose is observed in beaker number 2. Therefore, we can say that the optimum dose of coagulant is the dose added in beaker number 2, that is 10 ml per liter of water. In case the beaker with maximum dose give the maximum clarity, we would require to repeat the experiment with the higher dose value with some suitable increments. Now, once you know the optimum dose of coagulant, it is possible to calculate the quantity required of the coagulant for the purpose of water treatment. Thank you.